Let's start with the IIR filter design. So here this unit is split into three major halves. One is design of filter. Second one is conversion of filter into digital filter. Why? Because whatever filter we design will be in the form of analog. So we need a method to convert from analog to digital. And the third part is structures of IIR filter. So first let us concentrate on converting a filter from analog to digital. So we will be concentrating on the second part. So for conversion we have three methods. Number one is approximation of derivatives. Number two is bilinear transformation. Number three is impulse invariant. So let us go with the first method, approximation of derivatives. I'll call as AOD. So in approximation of derivatives, it's a very simple method. So here, wherever you find S in the given equation, replace S with 1 minus Z inverse by T. So for example, if H of S is given as 1 by S plus 10, then the solution will be like this. H of Z is equal to 1 by 1 minus Z inverse by T plus 10. So I have just replaced S with 1 minus Z inverse by T. And here T is an unknown term, and you can take T as 1 second. Whenever the value for T is not given, you can take it as 1 second. So substituting T is equal to 1, we will get 1 by 1 minus Z inverse plus 10. So it is again equal to 1 by 11 minus Z inverse. So the final answer is H of Z is equal to 1 minus 11 by Z inverse. So this is the answer. And in second method is called bilinear transformation. Here, wherever you find S, replace S with 2 by T into 1 minus Z inverse by 1 plus Z inverse. So let us take a similar problem again. Consider H of S, which is given as 1 by S plus 16. So here, replacing S with this particular equation, we will get 1 by 2 by T into 1 minus Z inverse by 1 plus Z inverse plus 16. So we have replaced S with the corresponding equation. Here we can consider T as 1 second, as I stated earlier. So this equation will become 1 by 2 into 1 minus Z inverse by 1 plus Z inverse plus 16. If you simplify again, you will get 1 by 2 minus 2 Z inverse plus 16 by 1 plus Z inverse, which can be further simplified as 1 by 2 minus 2z inverse plus 16 into 1 plus z inverse whole divided by 1 plus z inverse, which is again equal to 1 by 2 minus 2z inverse plus 16 plus 16z inverse. And we can take this 1 plus z inverse to the numerator, so this will become 1 plus z inverse. So here the final equation is 1 plus z inverse by 16 plus 2 18 plus 14 z inverse. So that is h of z. Okay, next method is impulse invariant. In this method, whenever you find the equation in this format 1 by s minus pk, it can be replaced as 1 by 1 minus e power pk t into z inverse. So let us see an example where h of s is given as 1 by s plus 2. So this equation can be written as 1 by s minus of minus 2. So this equation is in the format of 1 by s minus pk, the same above format. So for conversion, we have to replace this particular equation with this particular equation. So here the value of minus 2 is pk. So s minus pk. This equation can be replaced as 1 by 1 minus e power pk. The value for pk is minus 2 here, minus 2 into t z inverse. Again, we can take t as 1 second if it is not given or if it is not specified. So t is equal to 1 second. This equation will become 1 by 1 minus e power minus 2 into z inverse. And you can use the calculator to find the value for e power minus 2, and you can substitute in this equation. As I don't have a calculator now, I am stopping here. So this is h of z. Okay, let us see another example for impulse invariant method. As I stated earlier, whenever you find the equation in this format 1 by s minus pk, it can be replaced as 1 by 1 minus e power pk into t z inverse. Sometimes the given problem may not be in this format. So in such cases, we have to convert the given problem into this format before applying this solution. So let us see a problem here. H of s is equal to 1 by s square plus 5s plus 6. In this case, we don't have this equation. We don't have the given problem in the required equation format. So first we have to convert this equation into this format, and then we have to apply the transformation. So taking roots for this quadratic equation, 5 and 6. So if you add 2 and 3, you will get 5, and if you multiply, you will get 6. So the roots are plus 2 and is plus 3. So this is the equation. This is the roots for the given equation. Again, we have 1 by s plus 2 into s plus 3, which is not in this format. We can apply this equation only when the given equation is standalone. So here we have s plus 3 in multiplication, so we cannot apply. So in order to apply this particular equation, we have to take partial fraction for this. So if you take partial fraction, it will become a plus s plus 2 plus b by s plus 3. And if you solve for a and b, we'll get a equal to 1 and b equal to minus 1. So here this equation will become 1 by s plus 2 plus minus 1 by s plus 3. So now we have the equation in the required format. So we can write this equation as 1 by s minus of minus 2 plus minus 1 by s minus of minus 3. So finally we can convert into 1 by 1 minus e power pk, and the value for pk is minus 2 here, so minus 2 into t z inverse plus minus 1 by 1 minus e power minus 3t z inverse, since the value for pk is minus 3 here. And we can take t as 1 second, so the equation will become 1 by 1 minus e power minus 2 into z inverse minus 1 by 1 minus e power minus 3 into z inverse. So that is h of z. We can use the calculator to find the values for e power minus 2 and minus 3, and you can substitute here.